So the next thing that you're gonna do is now we're gonna do plotting. So again, we're gonna use a finer point, fine point, and then our first data point is 0, 0. So that would be 0x, 0y. Next is for time of 1 second, the velocity is 2. 1 second, 2. For 2 seconds, it's 4. So 2 and then 4. And then 3 seconds, you have 5.5. So 3 seconds, 5.5. So if you can see, you don't have 5.5, but you know that it's in between 4 and 6. So that would be somewhere here. So again, if you can see, this is in between this is your 5, but again, it's 5.5. Again, when that happens, you can always estimate. So you don't have to actually in your uh, y-axis, you don't need to place 5.5 there. So just follow again. Just try to estimate where would be the location of the particular value of 5.5. So for 4 seconds, it's 7.8. So 4 seconds, 7.8, it's close to 8 meters per second. So I'm just going to place somewhere there. At 5 seconds, it's 9.9. So it's almost 10. Okay. Now, after plotting, uh, by the way, uh, before the plotting part, after you try to label the x and the y axis, you need to write the title of your graph. And in this particular case, we're plotting the velocity against the time. So the title is just simply, you can just write velocity versus the time. Okay, so no need to indicate the units there. You just write the quantities. You start with the y variable, which is the velocity, and then the time, which is the x variable. So now I'm gonna connect this. If you can see, the general pattern is a straight line. So with the use of a ruler, I will try to locate the best line that would represent or at least fits all these data point. So fits, which means that, well, the line that could represent these data points. So the best curve that fits all the data points is a line. So that's a line. So therefore, I'm gonna draw a straight line. There you go. So this is now the graph that I have. So this is just a straight line. If you can see, this particular data point doesn't hit that line, so that's fine. That would be okay. At least this particular line would, if you can see, most of the data points actually is near or hits that particular line. But then again, just don't be tempted to like connect all your data points. That's wrong. It's not proper to actually do that. So let's answer the question. What is the relationship between time and velocity? So if this is an experiment, that's one of the things that you need to examine. What is the relationship of the two quantities involved in your experiment? So again, in this case, we're trying to examine what happens to your velocity as time goes by. So we can answer this one here. We can describe, so for our description, so we can say that as time increases, as time increases, velocity also increases. Okay, so that's our description. Now, since we got a straight line graph, straight line graph will actually gives us that velocity is directly proportional, directly proportional, so proportional to time. So your graphs gives you direct proportionality. So that means that there's a uniform increase uh, between the two variables. So that means that if you can see for every seconds, there's an equal amount of increase in the velocity. So that what it means to have uh, direct proportionality between two quantities. So the second question is the slope. Since this is a straight line, we can get the slope. So slope, you can define it as rise over run, or it's given by the change delta y over delta x, or that is y2 minus y1 divided by x2 minus x1. And remember that your y2 and x2 is actually coming from, this comes from your point 2 or p2 from your graph, and your y1 and x1, you can think of that as your p1, or a point in the graph designated as p1. So remember that in a linear graph, there's only one slope, and it is a constant value for that particular line. Okay, because remember, the slope of line is given by, or the equation of a line is given by mx plus b, and that m is a constant value called the slope. So in getting the slope of a line, all you need to do is identify this p1 and p2. So if, well, for easier calculation, you can use, if the line hits the origin, you can always use that one as your p1. So therefore, this is my p1, which is at 0, 0. And the second point, I need 2 points. So remember that I can use any of the points that hits along this line. But for simplicity, I think I've seen that this particular point also hits that one. So this, therefore, this is my P2. Remember that you cannot use this point because it is not along the line. Cannot use, can't use, since not along the line. So again, your line, which is represented by that uh, purple uh, purple line there, that hits your P1 and P2. So my P2 is 1 second and 2 meters per second. So for my calculation of the slope, that gives me y2 is 2 minus 0, and then this is 1 minus 0, and this gives me 2.0. But what would be the unit? Well, it is, the numerator is in meters per second because of this velocity over second. So therefore, that gives me meters per second squared. Again, that is coming from, this is meters per second over second. So that gives you meters per second squared. Okay. So that gives me meters per second squared. Because meter per second is that. So this is my slope. Okay. So as an extension, you can actually write your equation. So even though it's not part of the question here, but you can write the equation. The equation of your particular graph is, remember, equation is given by y equals to mx plus b. Y is represented by 2.0 plus 0. So b is equal to 2.0, b equals to 2t. Talk about that one next class. And also, next class we'll have a simple experiment that also somehow will able us to use the graph to get the a particular quantity. Okay.